Right, so start with number 9. Why is the following situation impossible? So why is it impossible? A skater glides along a circular path. She defines a certain point on the circle as her origin. So let's say she starts here. Later on, she passes through a point at which the distance she has travelled along the path from the origin is smaller than the magnitude of her displacement from the origin. So why is that impossible? Well, let me explain. Yeah, I'll explain first just to make sure we're clear. What they say is happening is she starts here, let's call that A, and then she moves around here, B, C, D, E, let's say, F, G. Okay. Now part of the difficulty here is the word distance and displacement. And in fact, next week in ESAP, you have one lesson on understanding the difference between the two words. But just to give it to you roughly, the distance is this piece here. You see the curved piece? That's the distance. Okay? And this is the distance. But this here is the displacement. Okay? So when she's at A, the distance is from A to B. So I don't know what that is, but the distance from A to B, I'll just write A to B. And then the displacement from A to B. Which will be bigger, the distance or the displacement?
Distance.
The distance will be bigger. Okay? It's just a straight line. Now, when she's at C, which is bigger, the distance or the displacement? Displacement. Now, what about when she's up here? Which is bigger? Distance. And when she's like over here? It's still distance. So do you get the idea? When you're going in a circle, the distance you travel is always more than the displacement. There's only one time when that's not true. Where would she have to be so that they're equal?
Is this like an example of question?
I don't think so. It's more just conceptual.
She has to stay in the same.
Yeah, if she doesn't move, then the distance is 0. Yeah, and the displacement is 0. So I suppose it could be equal, but as long as she's moving, then it can't be equal. It must be bigger. So it's impossible to have that. That is impossible. In fact, this is impossible as well. Okay? So the question wanted you to explain that. So, that what I said is the explanation. Okay? So that's number 9. So write that down if you need to. Yeah?
Kind of explanation also would be that she's going in circles.
Yeah.
So a circle is an arc, while they're saying vectors, and a vector is a straight line.
Yeah, that's fine as well. Yeah, so when you're traveling in a circle, you're moving on an arc, which will be bigger than the vector of displacement, which is a straight line. Yeah, if you wrote that down, that'd be full marks also. Be fine with that. Yeah.
Why is it possible distance equal displacement? If it is going to straight.
It's impossible for this example. Yeah. No. It can happen, especially if you're just going in a straight line. Then they will be equal. Yeah, no, you're right. It's only because of the circle. Yeah. Sorry, I should make that clear. For a circle. It's that. Okay. But like I said, there's an ESAP lesson about this vocabulary next week. Displacement and distance, speed and velocity. Okay. What one's next now? 11. Okay. Right, can I scroll down? No, you need a minute? Okay.
Will we do 11 graphically or normally?
I'm just going to do it using I and J because it's impossible for me to use the graph here. I mean, in the exam, that's what they'd want you to do anyways. Yeah. Okay, can I go down now? Yep, alright. So number 11. Yeah. So, you got your horizontal and you got your vertical. So you got one vector here on the vertical, that's called B. And then you have one vector here on the horizontal, that's called A. And you're told that this angle here is 30 degrees. Now, you're also told that B, they're both 3 meters, is that right? Yeah. So B would be 3J. Okay? A, we can do it as the triangle here. Do you remember the formula?
So, but isn't A is equals to B? As what mentioned in the question.
Their magnitudes are equal, but they're pointing in different directions. They are different vectors. Yeah. They have both magnitudes of 3.
Oh, so isn't it A should be 3 as well?
Not quite that. What'll happen is A will be 3 cos 30. That's the x and that's the y. I plus 3 sine 30 j. And we're using the formula I gave you yesterday. X is or cos theta, y is or sine theta. This is 3. This is 3 cos 30, that's 3 sine 30. Yeah. What was that called? The verb. No, the verb. The verb. No. Resolving. So you're resolving here. Okay. Can somebody well, cos 30 is root 3 over 2. Can someone give this to me as a decimal? What is it?
2.69.
2.69?
I.
Oh, 2.6i. Okay. And then the other one?
1.5.
Oh, 1.5.
1.5.
Yeah, 1.5j. Yeah.
It's a half of 3.
It's a half of 3, yeah. So there's A, there's B. Okay, so what do they want first? A plus B. A plus B, yeah. So A plus B, that will be 2.6 I plus 4.5j. Yeah, I'm doing it in one step. Yeah, so 3 plus 1.5. Now, they would also like the angle. So theta is tan inverse 4.5 over 2.6. What's that, please?
60 degrees.
Now, I would like the original. I don't know if you fixed that. Did that have a minus?
No,
It's 60. Okay. And then the magnitude is, no, I think it is, square root 2.6 squared plus 4.5 squared.
So it's actually 59.90.
I will settle for 60. What's this magnitude, though? What's this one? Yeah. 5.2 meters. So if you if you draw that, it would look, like this. 5.2 here, and then 60 degrees there.
But what if we're not allowed to use this method and we have to do it on the graphic? Then we have to use the rules of the parallel line.
Yeah, you'd have to take out your ruler and measure it, it would not be accurate.
But with angles it would be easier because the rules of parallel and perpendicular lines will help us.
No, I still think it'd be as difficult to measure the angle on your graph paper as the length.
But you don't need to measure, you can prove that the angle will be 60. It's easy. Like you have two parallel lines and another
In
one
this
goes-
case?
Yeah.
In this case, maybe, because the numbers are nice, 30 and 60,
but,
yeah.
But if make us do it in the other way?
You never know. You might be surprised. Don't assume anything. No. Okay, do you need me to do more parts of this? Because they ask you for B, C, and D. It's okay? Yeah? Okay. Do you have a question? No?
Yeah, it wasn't it easier just to write 3 tan 60 is equal to 5.19. We'll get this thing out to 5.2 meters.
3 tan. What are you getting there? Is that the magnitude or something? Or?
Yeah, I think for A plus B, it's the magnitude. 3 tan 60.
3 tan 60. I'm not sure how you got that though. Like what? Are you using any special rule or something?
I remember like school, when you add vectors, there was some kind of rules. And one of them was when you add tan, you put the number. Like 3 usually.
Yeah.
Magnitudes of 3. They want the magnitude of A plus B, so you do 3 tan 60.
I
Is there angle between the vector A and B? Because between A and B, x axis is 30. So that's 60 degrees left. So we use that 60 degrees and then we get 5.1.
I understand. So you're using a formula that makes use of the lengths and the angle between the lengths.
So basically use the school geometry.
That's okay. I don't think I've ever used that in physics class.
It's much longer than doing it in this.
But if it works fine. There's some formula like that
Oh, okay.
we use in maths class.
This is like
I need to check that because I've never used that one in physics class. But this, yeah, this could work. Yeah, I'll check it for you. Okay. You did this in geometry or in physics?
No, physics.
Oh, okay. So this is like a shortcut, is it? Kind of. Okay. All right. It's how you did it. I'll check it for you. Okay. 13 next. Okay. So we have a roller coaster moves. So if I try to draw this, 200 feet horizontally, and then rises 135 feet at an angle of 30 degrees. And then it travels 135 at an angle of 40 degrees. Like that. And I think I'll measure the 40 here.
It's horizontal. It's horizontal. I get the wrong answer because
So
I accidentally took 35 instead of 30.
Okay, so it wasn't what we thought then. It is right to do it this way. Okay. Good. No, we were having a talk earlier about that. Usually you measure these things in the horizontal. Okay. It didn't say explicitly in the question, but I suppose it did say 40 downwards. Anyways, they want to know the displacement. So they want you to add these 3 together to get this vector here at the end. So we have to add them together. Okay. So the first vector, or 1, that would be 200i, right? Yep. Or 2, that would be 135 cos 30i plus 135 sine 30j. This piece and then this piece. Okay. Now, just to be clear, there's a different color. Or 3, it's this piece, and I think we were talking about this tanish maybe the last class. You would have to put the minus in because it's in a different quadrant. So it would be it would be 135 cos 40 I minus, because it's pointing down, 135 sine 40 j. Okay, I need you to get the calculator. Oh yeah, I'm using the same formula for x and y, the or cos theta and the or sine theta.
Isn't it 40 is like this?
It's a bit hard to see. The triangle's upside down. what only matters is that the 40 is measured from the base of the triangle, which is actually here because the triangle's upside down. I'm not sure what the confusion is. Do you want to explain?
It says that it travels down 40 degrees.
Yeah.
So if the roller coaster was in this position,
yeah,
it should divert 40 degrees.
That is a good point. That's a good point.
And if that's the case, why is that starting from?
Yeah, no, that's a good point. Again, a little bit like I was saying earlier to Tal, they are being very unclear with how they specify this 40 degrees. Your point is perfectly reasonable. Don't we measure the 40 from the previous position?
Yeah, it is there.
All I can say is, maybe it's an English thing, but if somebody said to me 40 degrees downward, something about the word downward implies from the horizontal. Now that's not a great explanation, but the word downward, to me, it seems to suggest that you're measuring it from the horizontal instead of, as you're saying, measuring it from the previous angle it was at.
Basically, when they do not specify, the angle is usually on the horizontal.
Yeah, I mean, if you're not sure, the safest thing to do would be to measure from the horizontal. In the worst case scenario, you're wrong and I take away 1 mark, but that's not a big deal. You know, if this question was 6 marks. Okay. Maybe you want to highlight the word downward in the question, because there's something about that word that means from the horizontal. Okay, does somebody have this in decimal form? Let's see. So, R1 is still 200i. R2? Do we have R2, please?
I can give you R3.
If I wanted R3, I'd ask for R3. Yeah, give me R3 if you have it.
103.42
I.
minus 86.78 J.
Okay, and then R2? 116.91 I. Yeah. 1 sec, just get the J in here. What's the J? What is it? Plus or minus? Plus? Plus 67.5 J. Okay. So let's add these 3 vectors together to get the total. R1 plus R2 plus R3 equals. So if I add these i's together, what do I get? Please add them.
No.
220. Oh, 420.33i. Okay, now there's no j. Yeah, sorry, that's the 200. Yeah, and this j. So it'll be in. Would it be negative?
Yeah. Minus 19.
Oh yes, minus. Okay, so my graph up here is not so clear because I should have drawn this going down further.
It's
so
the same as the previous one.
Yeah. So you see that answer there? That's what you get if you add the 3 vectors together.
Now we need the
So yeah, this vector plus this one, when you add them together, it makes this vector here.
But isn't it asked for displacement?
Oh yes, I'm getting to it. Yeah, I'm just building it up, okay? So this vector here, this is the displacement. This is where the roller coaster is in total at the end. So the roller coaster has moved 420 and down 19 about. So if I just draw this vector here again, you're saying that the roller coaster, if it starts here, then it ends here. The displacement is this distance here. This is the displacement. So that means we want the magnitude. Magnitude is the length, how big, okay? So here, displacement equals square root 420.33 squared plus 19.28 squared. Okay, what's that?
400
Say again?
400.
So if I do three significant figures, 421. Yeah, three significant figures.
Yeah, the answer can have just approximately 400.
Oh, okay. Yeah.
And the angle is...
Oh, do they want the angle too?
They do not specify anywhere, but in the answer...
But the answer, there is an angle? Okay. So the angle here, theta, so this angle here is tan inverse minus 19.28 over 420.33. What's that, please?
2.6.
Minus 2.6.
Yeah.
It measured downwards. Yeah.
In the answer, it's 3, so same.
Oh, they rounded to 3. Okay. Okay. Now, question. Yes.
Can you scroll?
Yeah, scroll up. Here?
No, above.
Here?
Yeah. If they ask for displacement, why can't we just find the component of x and x just add it to 100?
That would just be the horizontal displacement. Yeah.
Because the angles are different, we have the different height of the...
No, but...
Of the
Yeah, but the idea that he has is fine. You want to say, get the x here, is it? And the x here, and add that to 200. That's fine. And if you do that, the answer you will get is 420.33.
Yeah.
Yeah, but you see, the problem is, that's how far it is out horizontally. It also has dropped in height as well. So it actually will be a little bit more than this number. If you think about it, if I travel from here to the corner of the room, your answer would just be the x part, the length of this wall. But you also need to consider the y part as well. So you would have to do what you did again for the y part, the heights.
But isn't if I consider y part is it's a distance instead of displacement?
What do you mean? You see, the problem is the roller coaster doesn't actually finish at the same height it began at.
Yeah.
So it actually travels more than what you're suggesting because it's not back at ground level, it's actually underground level. So you do need to consider the y. Now, if the roller coaster finished back at ground level, which normally roller coasters do, then what you're saying would give you the right answer. It's only because this one here, the roller coaster, it doesn't go back to ground level at the end. I think this is the confusion. But if it did start back at ground level, what you said would give you the right answer.
Can I copy this?
Yeah, do you need me to zoom out?
Yeah.
How far down can I go? Oh, well, actually, that's everything there, isn't it?
Starting from the R1. Yeah.
All right. Okay, write that down. Which number was that?
13.
Okay, some people had trouble with 13, wasn't it? Yeah. Okay, so in a moment now, 17, which is, I think, the most difficult one we said, isn't it? Yeah.
Is there a formula for displacement?
Not really. I mean, displacement just means add up all the vectors that describe its motion, you know? What do you mean? It means like a formula that will give you 421 as an answer.
Yeah.
Nah, not really. I mean, no, I think this is the way to be thinking about it. Okay. So I'll just give you a minute to write that down. Now, Um,
So why did you minus 86 points?
It's going down.
because for the last part of the journey, it's going down, so it's losing height instead of gaining height. It seems like this worksheet was quite difficult for people. What was the main difficulty here? Was it the language? Was it the ideas? It was mostly language issues, was it?
This question?
Like this entire worksheet, this page.
Yeah,
Language was what was complicated here, wasn't it? Yeah.
the exam questions, language is easier.
The exam is a little bit to the point. Yeah. I suppose with language, it is something that will get easier the more you read the book. Okay, are we ready for the next one?
Yeah.
Yep. So we're going to do 17. A minivan travels straight north in the right lane of a divided highway at 28 meters per second. A camper van passes the minivan and then changes from left lane into the right lane. As it does, the camper van on the road is a straight displacement at 8.5 degrees east of north. To avoid cutting off the minivan, the north-south distance between the camper's back bumper and the minivan's front bumper should not decrease. Can the camper be driven to satisfy this requirement? Explain your answer. Now that is difficult. So we'll try and break this down piece by piece, okay? So we'll try and draw this. Okay, can I scroll down now? Yeah? Okay. Right, so a minivan... okay, so I want to draw my road first. Okay, and just to be clear, that is La Road. You all read Rage comics, don't you? Anybody? Rage comics? No? No? Rage comics? You get my reference?
Yeah.
Yes? Okay, good. At least one person did. I'll get rid of that. So that's a road anyways, okay? A minivan travels straight north in the right lane of a divided highway. So the minivan is here. And it is going north at 28 meters per second. A camper passes the minivan and then changes from the left lane into the right lane. So what you have here, I'll do it in a different color. Yeah, this is minivan. And then here is a camper van. Doesn't really matter. It's just another car. And then what happens, it passes, changes from left lane into the right lane. As it does, the camper's path on the road is a straight displacement at 8.5 degrees east of north. So what happens here is this car drives in front of that car. And they're saying, now there's a little bit of English here. You see this piece here, 8.5 degrees, where's it gone? East of north. What does that mean? That means
1 o'clock.
Yeah, 1 o'clock. You start at north, so this is north, and you measure east 8.5 degrees. Okay. To avoid cutting off the minivan, the north-south distance between the camper's back bumper and the minivan's front bumper should not decrease. Can the camper van be driven to satisfy this requirement? So in other words, the question is it possible that they don't crash? Okay, is that possible? So, does it say how fast this one's going?
The van is 28 meters per second.
Oh, this is 28, is it?
Minivan is 28.
Yeah, that's that one. And then what about the camper?
Nothing.
Oh, okay. So we want to know, is it possible maybe to pick a speed? Yeah. Now, I feel like the answer is going to be yes.
Yeah, yes.
I suppose, yeah, because I mean, if it's going fast enough, it can pull out in front, right? I think the real question is how fast? Yeah, how fast does it need to go so that they don't crash? Okay, so what I'll do is, I think, resolve this vector. So this part here would that be cos or sine? No, because you're measuring the angle here. This is like the base of the triangle. You see, it's a little bit sideways.
So is that like the x?
Yes, yeah, it's like that, yeah. But I'm going to call it J still. But if you visualize it like that, yeah. So for the camper van, can you type? Oh no, actually we don't have it. So it'll be x cos 8.5, x cos 8.5 I, and then what's the j? It would be x sine 8.5 j. And then what's the velocity of the minivan? 28 j. Yeah? These are all meters per second. Yeah, well, it's going up, so j. Yeah, you seem a bit confused.
So, yeah, isn't it?
No. I said it's, if you want to visual it for the triangle, it's like that's the x-axis for measuring. But here, let me just give you a quick trick. If this here is A, and I want the vertical and the horizontal, this one will be the sine and this one will be the cos. But if I measure A here and I want the horizontal and the vertical, this will be cos and this will be sine. In other words, the cos is on the side that touches the angle. You see, the angle touches the vertical, so the vertical is cos. The angle touches the horizontal, so the horizontal is cos. That's a quick way to do it. So what he was saying is it's like that's the base in this situation. I don't know if this is complicating things. Whatever side is touching the angle, that's the cosine, the cos. Okay. Now, I need this one here. So there's the horizontal and there's the vertical. So let me draw some situations. I'll draw it on the side here. So let's imagine this here, this is 28. Let's say this is 28 meters per second, this is 28 meters per second, and this is 1 meter per second. Who can tell me what would happen here between the two cars? Who can picture that? Yep. Why though?
Because their J speed is the same.
Yeah.
And when it will start turning right, it will just...
That's it. Here, they both have a vertical of 28. So they both are going up the road at 28. But the one on the left is also going to the right with 1 meter per second. So they'll go up, but then they'll start to get closer together. Okay? So the problem is we don't want 28 there. We want something bigger than 28. Yeah? Much bigger, yeah. How much bigger? Well, it depends on how long the van is. Okay? So let's put in just a rough estimate. Okay? What is it? It's a minivan. So how long will a minivan be?
4 meters.
We say 4 meters? Something like this, 4 meters. So what you want is that I wish I had something to point with. When the camper van moves in front, if the minivan is 4 meters long, you want the camper van to travel 4 meters in front of the minivan. How else can I explain this? If I got some props or something here. Yeah. Right. Okay. So this is 4 meters, and let's say they're like this. Yeah. Okay. So you want this one here. Look. This is the one over here. You want this one to pull in front, okay? But you want it just about to get in front. So how far has this travelled vertically compared to this? 4 meters. Yeah? 4 meters. Okay? Let's imagine it only travels 2 meters. What would happen? It'd be like that. Yeah? So we want it maybe to be like at least 4 meters. Something like this. Okay. And also, we want this to be more than 28. Okay? What's that? Just a bit bigger, maybe, yeah.
Maybe less than 1 meter.
So what we'll do is, I think it'd be good actually if we look at different situations. And yeah, this will be a bit of fun. Where's my office program? Okay. So what I'm going to do is I'm going to do a little table. How far the first car travels, how far the second car travels, and we can see different situations, okay? So this one here can be, what did I call the one on the left? Camper van, was it? C, X, Y, X, Y. Problem? If you have a question, ask me, it's okay. Look, please. Here is time. Okay. 0, 1, 2, 3, 4, 5, 6, 7 seconds. Okay, let's make this one easy. The minifan, is that traveling, does that have any I speed? Does it have an I? No, it only has J. What's the J? 28. So after 1 second, if it's traveling 28 meters per second, how far has it moved along the road? 28 meters. Then after 2 seconds, yeah, it'll be another 28. Like this. But the X is still always going to be 0. You see that? Liz, hey, come on. You can ask the question in a moment, okay? It's good that you're working together, but this is difficult. I want you to try and focus here. Are you looking? Now, let's say for the other one, let's make this one 29 and 1, okay? As an example. So if this is, that should start after 1 second. Okay. So after 1 second, it's 29. Then it's 29 again. So you see, how far ahead is this one? It's 1 meter ahead on the road, isn't it? Then after another second, how far ahead is it? 2 meters ahead. You see, so the car on the left is going faster. Now, if I said this is 1 meter for the I, how far has it travelled after 1 second? Horizontally, just 1 meter. And then after another second, another 1 meter, isn't it? So let me draw this on the board, my little table here. Oh dear. So here, this one travels 28, then 56, then 84. Then the one on the left, 29, and 1 this way. So it's going that way. Okay? And then after another second, 29 and 1. Okay? Now you notice that it also depends on how wide the road is. So how wide is a road?
It's a highway.
It's pretty wide. So what would we say for a highway? How far apart are the cars? 3 meters? Yeah, yeah. So how long until this one has moved into this lane? 3 meters, and it's going 1 meter each second, so it'll take 3 seconds, wouldn't it? Yeah. So after 3 seconds, how far has this car travelled vertically after 3 seconds? 84. Oh, sorry, 87. And how far has this car travelled? And what's the difference? 3 meters. And what did we say we think the car's length is? 4 meters. So will they crash or not? They'll crash. So I think 1 meter here is maybe too quick. So we could make this smaller, or we could make this one bigger. Let's make this one bigger. So if we make this 30 and 1, 30 and 1, 30 and 1. So after 3 seconds, how far has this travelled? 90. And how far has this one travelled? And the difference will be 6. So that's enough space then so that they don't crash. So if it was going 30i plus 1j, that would be good. Okay? But we don't want I and j. We need to change it back into polar, the magnitude and the angle. Okay? So if I go back to the question now. Oh, by the way, this one here, it's only there's many answers. You know, like, for example, if I said the car went 300, right? After 1 second, what would happen? It would move out 1 and then up 300. Will that be enough space?
Yeah, but the point of the question is to find the minimum speed.
Well, does it say minimum? It doesn't.
But we have to prove it. So
No.
But that's what it is, and they just find.
No. So fucking listen carefully to the vocabulary. The question did not say find the minimum. It just said prove that it's possible.
Yeah.
So it's enough to find one example of when it's possible.
Okay, yeah, but we can put 1,000.
Yeah, but at least make it believable. Yeah, but you're right.
Even if we would put 30, it would be alright.
Yeah.
Even 29 would be alright. But the most interesting thing is to find the minimum.
Homework for you if you want. You tell me tomorrow.
But that's the point of the question.
No, that's not the point of the question. The point of this question is to get you thinking about horizontal and vertical, that it's important to consider both.
But this...
Don't worry, Tal. It will get more difficult. For week number one, I'm trying to keep it easy.
I just think that the method that we use right now is not like... It's not a scientific method. It's just the...
Of course it's not. I just said...
point in...
Tal, you're wrecking my head. Listen carefully. I know it's not. I'm just doing this for fun. That's all.
Can we solve it in the normal way?
Maybe.
It should be easy. It's like one step.
Maybe. If I'm in a good mood. Right now I'm tired. Alright, can we finish it this way and then some other time we'll do it? The minimum then, yes. No, I get what you're saying, but this is only week number 1, so we're keeping it light, okay? Or like Diet Coke or something. Alright, where was I? Yes, so... What did we say we would... Oh, jeepers. What did we say we'd like? We'd like 1i and 30j. That's what we want. So you can actually figure out what the x is because you need this to be true. Okay? But the problem is you need this to be true also. You know, so you might not be able to get 1 and 30. Maybe you can. Can somebody type in, please, x cos 8.5 equals 1. So what would x equal? Did I have it back? No, 1i and 30j.
It's 1.01.
The x is 1 point what?
1.01.
1.01. Okay, 1.01. And then if I use it this way, the x is what? equals 30. So x equals
202.96.
2.0.
202.96.
Okay.
No, 202.123.
Okay. 202.
0.96.
Okay, 202. So you see, we don't have the same value of x. So the combination of 1 and 30 is not possible. Okay? So this is actually being much more difficult. 202 seems too big. 202, yeah. X 1.01. If I make this, actually this is turning out to be very difficult. Right, just give me 30 seconds to think about this. Yeah, let me go back to this. Okay. So the problem is, here, we can't choose the x and the y. We can only choose the speed of the car. So if you remember from the formula, x is the speed. Let me write the speed here. Let's say 30. This one here would be 30 times cos 8.5. I don't know if Excel uses degrees. Can someone type in 30 cos 8.5 and see if we get the same number here?
39.67.
Oh, so they don't use degrees. Okay. Okay. You got that, was it?
Mm-hmm.
And then the y was the speed, which is, in this example, 30. And then here it would be same thing. Equals sine. Okay. Can you type in 30 sine 8.5 and see if you get this?
4.4.
Yeah. Okay. Right, there we go. Okay, there we go. Right. Cancel. 3 times that one. 3 times that one. Okay, 3 seconds. Maybe we'll do 4 seconds. 4 times that one. 4 times that one. Okay. So here, if the car's going, what was the speed of the first car? 28. Yeah, if they're both going 28, did that even change? Yeah, it did. Okay. Now look, if the first car's going 28, after 1 second, how far has the car travelled? 4.13. And how far has the other car travelled? 28. So it will fall underneath. So if I increase this, let's say to 30. Still a problem, right? Still falling behind. Okay. What about if I make it 40? Something's going wrong here. I'm spending too much time on this. Alright, forget about this one. Did you do it this way? I really didn't want to do that.
If I put this car is like a point because it's far away it looks point. So, and I didn't care about lens or car.
Yeah, but
And I was thinking it is pass to right.
yeah,
It's in a second.
yeah.
And I didn't care about
Secondary
speed.
attention.
Just one.
And I did
I
too.
for 1 second. It's going to 228 meter and this is
Ah, so you made this 28.
yeah. It's for 1 second. 1 second. I just imagine it's going to everything is finished for 1 second.
So you did it just 1 second, and you did it as 28. But my problem, yeah, but the problem with 28 is if they're both going 28, that means they stay together. So,
No, it's 28 is the minivan, and this is.
oh, okay, this one 28, and what about the other one?
The other one is 20 on here. 28.
Ah, okay.
More than 28.3. For 2 seconds, it's 56, and this range is.
It'd be more than
She
56.
used just one rule. That's why it goes like scientific. That's all she did. And she took like
But what's the difference here? 56.6 and
And this is just imagine for 2 seconds. This is for 1 second. So anyway, it's the average of the speed is same.
she's completely right.
don't use the word completely.
Yeah, it is. This is the easiest way. The formula that you gave us on the first lesson. What y equals to what
Okay.
x equals to.
I would not say completely right, I'd say suitably right. You're right, thank you. That'll do. I've been messing about here with Excel. I'm sorry, I thought I was going to do something cool here in Excel. I realise it just looks stupid now. So apologies for that. Okay. Right. Hey, do you want to show the class how to do it? Yeah, go on actually, don't be shy. After all, you did suggest it. Where's my eraser gone? Now don't be shy. They'll be nice to you, won't you guys? No. It's good practice of English. Now listen carefully and write it down.
What was it?
Oh yeah, you might need the question, yeah? Here you go.
But I put everything finished for 1 second, and I didn't care about any speed and any second, any time.
Okay, does that make sense so far? Yeah? Okay. Go ahead. By the way, what's that just underneath there? 1S2B?
Yeah.
What's that?
1 second.
Oh, 1 second and 28 meters. Okay. 2 seconds, 56 meters. Okay.
Then and I was thinking it's for 1 second, and this distance
Distance?
is 28 meter,
Yeah.
and then it is going to for 1 second this distance,
Yeah.
Okay.
and then
guess. Yeah. Yeah, explain, what's that?
It's
Times
it's the
28.
Oh.
Sine
Yes.
81.5 times y.
Yeah.
No,
Yeah, no, you're right, you're right.
Oh, yeah.
Yeah.
No.
What?
Yeah.
What?
Yeah,
No.
what? Let's start it again. This is right. Y equals or sine theta. Yeah, and x equals or cos theta. So she's just rearranging it. Y over or equals sine theta. Now we know what the theta is. What's the theta?
81.81.
Yeah.
Oh, yes.
Sine theta.
Just find out.
You're making this, now you're making it complicated like me. You know this here. You don't have any choice. They tell you this in the question, yeah? And you don't have...
Oh, what? I was confused.
yeah, okay.
R equals to y over sine theta.
You're right, yeah, no, keep going. Yes, equals sine 81.5. Good. So she can get the or from this.
Okay.
So can someone do that on the calculator, or what is it?
No, I was wrong.
No, you were
No,
completely
no,
right.
no.
Yes, you were right.
I need R.
Yeah, she needs or. So or equals...
Jesus Christ. Come on.
Are you sure? I think this might be upside down.
Yes, this is upside down.
Yeah, here. Try it again. R equals, there we go. Okay, so equals 28 over sine 81.5. What's that, please?
28.3.
28 over
Just write the answer.
sine 81.5. Yeah. Equals
28.3.
28.3.
It has to be faster than 28.6.
Yeah, now, you can sit down now. Good job. Now, it's okay, but if you look at her example here, after 1 second, how far has this travelled? 28. And then after 1 second, she said the other one travelled horizontally 28. And this piece here, she worked it out
28.3.
28.3. And if you want, you can type in and work out the vertical here. But my problem with this answer is that it means that this car is only...
3 meters now.
no, it's worse than that actually, because this car, they're both 28, which means they both, well...
Is all this just because he wants to go on the right side?
Yeah.
Right.
See, I don't think this will work, because this car, after once, like if you draw it here, look, after 1 second, this car will be here, and then it will be here, and this distance, what is it? 28. And this distance, 28.3. And this distance, whatever, you can work it out. After 1 second, how far will this car move? From here up to 28.
So that's why she said that it has to be faster than 28.
Yeah, but how much faster? It needs to be faster than this.
It's
Yeah.
at least 28.3.
Yeah, well,
So it's equal to it or bigger.
I would say, no, I'd say it must be bigger than 28.3. But in fact, I think it must be much bigger than this.
No.
Hmm?
It was the answer.
The answer at the back?
Yeah.
No. I wouldn't accept that. But your idea is right. The only thing I will do in her method is I'll change this 28 to 32. because then that would mean after 1 second it would be up here, and it has a bit of space between the cars. Okay, so if I just change this to 32, what would you get now? Yeah, so for me, I'd say 32.35, so that you can give a space between the cars. Now look, the only reason I'm saying that is because in the question it said, make sure that the bumper of this car doesn't crash into the bumper of this car. But if it was 28.3, then both cars would be at the same place. So yes.
I think the information is not enough.
I know it's not enough. It's a terrible question. It's a terrible question. And I was hoping that what I was picturing was in Excel, I'll do a nice Excel graph, and then you can see, oh, the car's here, oh, then the car's here, so, you know, but that didn't work out. So I would say this. This one, I think, will be fine.
Yeah. We're going to have this kind of question.
Oh, no. This is only for fun. All right. I think we spent too much time on that. So let's look at the next one, 19 and 21 then. No. Sure, that question was practically a break. You didn't do any work for it.
I solved it.
Yeah, and then you just sit back and relax as you watch us.
I solved it like 5 seconds before you came to check her.
Yeah, and then for the last few minutes you were just sit back and relax and watch this one. Yeah.
What about others?
What about the others? Does anyone else need a break? No. Okay, so we're going on then to the next one. 19. Look, it'll toughen you up. Okay? Obtain an expression in, I think, Tanish, you were asking me what does component form mean. Do you remember what component form is? What is it? Cartesian form. Okay, so I'll just do one of these as an example. The vector is 150 degrees and that's that graph, and 12.8 long. Now, if that's 150, how big is this piece? 30. So what would be the formula for this piece? It'll be 12.8 cos 30 with a minus. What's wrong? Oh, because I think the question says, well, if it didn't say, you always measure from this axis here. What? Yeah, what are you asking me? 150 is less than 180, which are the first two quadrants. No, it does go anti-clockwise, yeah? Yeah. No, this is the normal way to do it. You start at the x and you go anti-clockwise. No? Well, it's only a convention. It might be different in different countries.
No,
is it universal? Anyways, here, when we measure angles, we always measure from the x and we go anti-clockwise around.
So in here, you start from the
bearing is something different. I don't think they used that word here, did they? They didn't. But you're right. In bearing, I believe you start at the north and go east. Correct. But they didn't use that word here, so we use it this way. But that's a good point. I don't even think that word is part of the vocabulary of this course. But no, good point. It's going to be like this though. Okay? Right, what's that please on the calculator? And then the other one here.
So is that negative because it goes?
Correct, it's going to the left, yeah. And the other one would be 12.8 sine 30. Okay, so what's the first one?
11.4.
Minus 11.1i plus 6.4j. And then it's the same for all the other parts. Okay? And then lastly, 21. Oh, but do you need to write that down? Yeah, okay.
It's 1980.
Yeah, just the first part. They're all the same. I'm not going to do 21. Have a look at 21. It is exactly the same idea as the roller coaster in number 13. Completely the same. So I won't even bother doing that. It'll be the same thing. Alright. Now I did spend more time doing this exercise, but that's fine, because I'd rather spend more time to make sure everybody understands this than to go ahead and people still be confused. Okay? Because as you know, vectors will be important for physics for the rest of the course. Okay? So we will use vectors in other topics. So what the situation is, if you look now at page 34, see 34? This is our first really mechanics, physics topic. You know, up until now we've just been kind of looking at maths, really. But now we're starting to look at actual physics problems, okay? So if we start on 34. Now you see part A there is scalars and vectors. We already took care of that. And B we took care of, and C we took care of. So actually, we're going to start with, on page 35, moments. Okay? You know this topic already, do you? Yeah. Okay. Now, what I'd like you to do before I start is a small exercise. Do you know this word force? Yes? I would like you to try your best to write down the definition of force. Wait, in your words, okay? And I'll see what different people say. So give me one sentence, tell me what force is. I mean, we all understand force from English, you know, like a lot of force, you know. But try to give me your definition.
Force is a push and pull.
Yeah. So like whatever you feel is the definition, write it down and we'll see what people say. That is one common definition I hear of force, yeah. All right. So you have one definition, yeah? So what did you go with?
Find out the process to change an object's given position of
Good, okay, that's fine, yeah. And Tanish, what was your one you had?
Force is a push and pull.
Yep, good, yeah. A push or a pull. I think that's a very American type of definition. Yeah. Did you go to American school by any chance?
No, it's just the definition I just did in high school.
Oh, okay, all right, yeah. What else have we got? Does anyone else have one? Yeah, go ahead. Yeah.
I wrote asserted motion in space-time exerted on or by an object.
Yeah, okay. So good, you have the verb exerted, which is good, yeah. Anyone else have one? Yeah?
Power that makes speed.
Good, okay, something that makes a speed, yeah. Good, yeah.
Hiya.
Hey.
I'm just here.
You here to do some physics? What?
Yeah, where's the rest of the group?
This is everybody who does physics.
Yeah, well,
Do you want biology students?
I want everybody.
You have to go to 2 rooms. But fortunately for you, the other room is just the big room downstairs.
Well,
Yeah.
Is this?
Yeah.
Okay, because I have a message for Eli here. We will go to bank today. So if you can be in my office at 1:45. Is that okay?
Where?
No, just for Eli.
Oh.
Okay? And do you have your passport with you? Yeah?
What, do you know when the person will receive our cards?
Some of students' letters already, so they're in the post. So maybe
No, I mean student card.
on the student card. It usually takes unfortunately around a week, so I asked them to print them out for you already, hopefully next week. Okay? 1:45. Okay?
Oh no, that's okay. So you were saying a power that causes a speed, is it? Good. Anyone else have one they want to offer? Now, all your definitions are good, and you all have the right idea. So your one, it's like saying a force is that which causes an acceleration. Do you remember did we talk about acceleration a little bit maybe? Acceleration, what does that mean? It just means, I think what you're saying, change
in velocity.
of speed or velocity, as you were saying, yeah. Now, your definition was force, causes a push or a pull, is
Force
it?
is a push or a pull.
It is a push
Or a pull.
or a pull. And you had one as well. What was your one?
Certain motion in space-time exerted on or by an object.
Yeah, so you could say force causes a change in motion, in space and time. And you said exerted, so that kind of is related to this definition of force is something, is an exertion that causes that is a push or a pull, yeah. I'm only writing these down, I just want to see if people have the idea of force in their head correctly, which they do. When we study Newton, we will do a proper definition for the exam. But for today, we're just going to do an informal definition, that's all. And I wanted to see what people had, okay? So what we're going to look at now, moments. You don't need to write that down unless you want to, but I need to go on. So, moments. A moment is a turn-in force. That is a moment is what makes a mass turn. And another word for turn, what's another word for turn? Rotate, yeah. Or revolve, maybe. No, I don't even need to write that. So when we say moment, let me give you an example. Look here. So this, as you were saying, Tanish, a push or a pull. So this is a force because I'm pulling it, or maybe because I'm pushing it. But this is a special type of force because it makes it turn. Okay? So that's a special type of force called a moment. It's when you make something turn in a circle. Okay? So there are other words for moment, though. Does anyone know another word for moment? Synonyms for moment? There are other synonyms for moment. One, if you think about cars.
Momentum.
Not momentum. Does anyone know the word torque?
Yeah.
Yeah, you usually hear it with cars, don't you, with the wheels turning.
Yeah.
Torque. And there's another one as well. Well, it's actually simple. Another word for moment is turning force. So, you have moment, turning force, or torque. Okay? So other words that mean moment is turning force, or another word is torque. T-O-R-Q-U-E. Torque. They also mean moment, turning force. Okay? Now, is there a formula to calculate it? There is, so that's what I'm going to do with you now. Can I scroll down? Do you have this? Yeah. So if we take the example with the door, So if I am pushing on the door like this with force F, okay, and let's say the door here is distance D from there to there, the turning force, which I'll use letter L, I don't know what they use in the book, I don't think they do use a letter, that's just the force multiply the distance. Now, what I think is unfortunate about this book is that they have you doing, I don't know why they do this in the book, but they have you learning turning force before you learn force. Why they do this, I don't know. I think the main reason is because this chapter uses a lot of vectors. Okay? So, force here. Now, that's the force there. You have to be careful though. It's important that the force is perpendicular. Do you remember this word perpendicular? 90 degrees. If it's not perpendicular, if I pull it like this, it's not this formula. It's a different formula. So I'll do it in blue. Let's say I push it this way here, F, and instead of 90 degrees, there's an angle here.
So what's the L stand?
That's turning force. Another letter people sometimes use is this thing that looks like a T, but not theta, no, tau, but turning force. Turning force. Anyways, if there's an angle here, the turning force will not be this. It'll be very similar to it. It'll be F multiply D multiply cos theta. Why is it cos theta? Well, if you think about it, what you do is you break it up into this piece and you break it up into this piece. Sorry, I didn't. No, Stephen. No, bad Stephen. Not theta. Not cos. Sine theta. If you measure the theta from here, if you measure the theta from this way, then it would be cos. It depends which way you measure the theta from.
Theta would be 90.
Yeah, in fact, you could use this formula here, except you make the theta 90. And if you want to use this formula, what would the theta need to be when it's perpendicular? Would it still be 90?
Yeah.
No, it'd be 0 because you're measuring out from this direction. Will I draw it again? Yeah, I think I'll draw it bigger. Alright, so this is the door, and then this is the force. If I measure the angle here, the formula would be D. F D sine theta. What would happen if the theta is 90 and it's perpendicular? What's sine 90? Do you know this one? It's 1. So it would just become FD. Now, imagine instead I measure the angle here. Let's call it alpha. It wouldn't be FD sine theta. It would be FD cos alpha, yeah. Now, you might say, oh, how will I remember which way around it is? Well, let me show you the logic. When we did our factors, we can break it up into this direction and this direction. This one touches the angle. So is this cos or sine? Cos. So this is F cos theta. And then this one here, what would that be? F sine theta. Now we don't care about that. Why not? Why do I not care about that one? Why do I only care about this one? Yeah, but why is that one not important? Well, it's not important because if I'm turning the door, any force that goes towards the hinge doesn't make the door turn. Like if I push here, it's not turning because the force is going to the hinge. You only care about the force that's this direction because that's the one that makes it turn. That that force there, the F cos theta? It does nothing. It does nothing. Okay? Only the F sine theta is actually doing something. So that gives us a kind of little result. This point here is called the turn-in point. Any force directed to the turn-in point will not cause a rotation. Will not cause it to turn, I'll just say. Make it simple. So if you want to turn something, you can't have the force going towards the turning point. It won't make it turn. Okay. Is that okay? I know it's kind of much to be dealing with as a first topic. All right. Well, what is important is this, okay? So we don't care about that one. We only care about that one. And you can see why if I put the angle here instead, will this be cos or sine? No, this one will be cos then. If I put it here, the angle instead. That one would be cos, and then this one here would be sine.
So we would have to measure it with cos.
Yes, exactly. Yes. Okay, can I go down? Yep. All right. So we'll just do a little example to start with. I'm sure you've seen this one. Let's make it a... I'll try to draw this. Does anyone know what I'm trying to draw? Oh, very good. A wrench. You know, you put it... I don't even think there is any screws around here. You know, if you have a screw on the wall or wherever, you put the wrench on and you tighten it. Or like in a car, yeah. So your hand will be here, and you will, for example, if you're doing this, you're pulling down with 100, let's say 100 newtons. How long do you think this wrench will be? 10, 20 centimeters? Yeah. So that's 0.20 meters. So what's the turning force here? It'd be this number, multiply this number, so what's that? 20. Now, what's the unit? Newton meters. How did I work that out? Well, what's the formula for turning force? It's force multiplied distance. What's the unit for turning force? That is the unit for force multiplied the unit for distance. What's the unit for force? Newton, and for distance, meter. Okay, so that's 20 Newton meters. Now, if I go up, it's still 20, right? The direction's not important. But it is sometimes important for the question to be clear which way you're going. Are you turning up or are you turning down? So what we usually do, if you turn this way, you say that's minus, and if you turn this way, you say that's plus. But in fact, if you say plus and minus, that's okay, once you keep it the same for the question. Okay? So actually, you know what? I think I'll go plus and minus, like this. So if it's going up, it'd be plus 20, and if it's going down, it'd be minus 20. Okay?
Copy that down.
Yeah, try your best to draw it. Yeah. Yeah.
L is the length? What does L stand for?
L stands for turning force.
D.
We can't use T because T is already used for time. So, yeah.
So you can use tau.
Yeah, I did use tau last year, but
I think that in the exam they usually say torque. Not
yeah, they don't really use a letter. They would say
but
torque.
When they say torque, you have to use that.
Yeah, I used tau last year, but people kept thinking and calling it T. So I thought L is the other letter you can use, and that clearly doesn't look like a T. Yeah. If you want to use tau, that's fine. Okay, now we're going to look at a special situation. Oh, wait, do you need time for that? Yeah. Okay. Can I go now to the next part? Yes? Okay. So here's a special situation like here with the lid. Look, when you turn something this way, okay, there is one force that goes up and there's one force that goes down. And they're equal. And the reason that they're equal, well, maybe somebody can tell me. What would happen if they weren't equal? Now, it would still open, but what would happen? So I'm turning it, okay, and let's say this force is bigger than this force, and I turn.
It will fall this way. It will fall this way.
Very good. As I turn it, it would move forward that way.
Yeah.
So as I turn it off, it would, jump off this way. So if I want to keep it here, I need to turn it. The two forces have to be equal. Okay. This is a special situation of turning force. It's called a couple. That's when you have two forces that cause it to turn and they're equal. And it's a common situation. It's a common situation. Right. If this here is D, how big is this piece? Yeah, well, using the letter D. D over 2. So how big is this turning force? Yeah, what's the value of it using the formula I gave you? It would be F multiply D over 2. What about this turning force? F multiply D over 2. Now, is this going clockwise or anti-clockwise? Anti-clockwise, so it's positive. Is this going clockwise or anti-clockwise? Anti-clockwise, yeah. So do these combine or cancel? Combine.
The turning point is in the middle.
Yeah, it's turning around the middle. So this would be FD over 2 plus FD over 2. So in total,
FD.
just FD. Okay. So this is the formula for a couple. And it looks exactly the same as what we just did, doesn't it? The only difference is you have a big D instead of a small d. Okay. And for these problems, it's always 90 degrees. Okay? Always 90. Now, let me see. Give you something to try. Okay. Let me just. Can I go down? Yeah.
Does this have anything to do with the scientific results?
So what is that?
Not so much. What it'll mostly be dealing with is equilibrium. Systems in balance. But you can relate it to centripetal force. We usually don't for this topic. We usually just deal with it for equilibrium problems.
Why is it both sides are positive?
Because both cause it to turn anti-clockwise.
They have the same direction.
Yeah.
So
it makes it turn. They both make it turn anti-clockwise.
So
yeah.
add them. If they would be
if both F's were going up, what would happen? One would turn left and the other would turn right, and nothing happens. Okay, I'll give you some small examples to do now. Hey, dude, I'll tell you when you're finished. Don't worry. I want my lunch much more than you do. Okay, so here's an example here, just some basic examples. So this is 10 newtons, this is 5 newtons. So in total, what do we have? Yeah, it'll just be 5 newtons this way. Okay, that's fine. But now let's look at a more difficult one. So you don't even need to write that one down. Okay. Now let's look at turning force. So let's say this is 1 meter. This here is 2 meters. I have 10 newtons this way, and I have 20 newtons this way. And I want to know what's the total turning force. Okay. That's 1. That's 2. Alright, so this one here. How much turning force do I get from the first one? If this is the turning point. So it's 10 Newton meters. And how much do I get from the second one?
40.
No. 60. Why 60?
Because it's from the turning point.
Very good, it's from the turning point. So it's that add together, multiply this.
But what about positive?
Very good, but it's not positive. Because this is going the opposite direction. So if we say anti-clockwise is positive, then... the heck?
Can we choose either one as positive?
You can't. What's happened to my pen? Positive, I would have to make this one negative. But you can do it the other way, that's fine. So what's the total? 50 Newton meters. Okay. Don't write that one down, but do this one for me. This is 3 meters. Here is 2 meters. This one's 10 newtons. This one here is X newtons. I want you to tell me what X needs to be so that it does not turn.
Where is the turning point?
Here. So tell me what X must be. I want you to work out what X must be so it doesn't turn. Is it? Yeah, actually might be. Yeah, I think it is. Yeah. But how do you get that? How would you write this down?
You find the
yeah. Well, the turning force. How much do you get from the first one? 30 with a minus. And how much do you get from the second one?
You have to get 32.
Yeah, no, but how much if we just leave it as X? 6X. And what do you want it to equal if it's not turning? Not turning is 0.
It's 5x.
Oh, it's 5X, sorry. The answer is 6, yeah. So what does X equal here? X would be 6. Okay. Now the reason I'm showing you this isn't even the problem I want to do. It's just building up the idea. So I think we'll look at it next time, but I just want to draw the picture for you.
Why is that 0?
Because I told you it's not turning. Can I scroll down? Yep. So this is what we're working up to for the next class. And this is the type of problem you get in the exam. So you have a wall here, and you have, like a flag pole here. Yeah. Yeah. Look, we'll make it American. Yeah. So you got your flagpole here, okay, and you have your rope here, your string here. Yeah. You know which country? USA. Okay. So here's angle here. Here's a force here. There's also another force. What force is pulling this pole down to the earth? The weight, the gravity, yeah. And then you have a force here as well, don't you? So this is what we're going to try and do in the next class. No, we're not. I'm just showing you the idea of what we'll do in the next class. So if you look at this here, we need to use vectors because the t needs to be, what's the verb? What verb do we use for t to break it into x and y? Resolve.
T is tension.
Tension, yeah. So we need to resolve the t. Yeah? Also, is this pole turning? Is it turning? No. So what is the turning force? The turning force needs to be 0. Is this pole moving up? No. So the up force needs to equal the down force. And is the pole moving left or right? No. So the left force needs to equal the right force. So the idea I'm trying to get to here, does anyone know the word that describes when the system is balanced? Equilibrium. Okay. So if you look here in your book at page 36. Yeah, equilibrium force is there. Is equilibrium 36? That's what we're going to spend the next class next week doing, is equilibrium problems. Okay. Now, I feel bad if I don't give you homework, so I better give you something. Page 32. You know what? I'm feeling generous. We won't have any homework then. Okay. So we'll just start the next topic next week, alright? I'll just have to give you extra work next week.